In the previous class, we talked about how do we use the relational schema diagram to represent a database that we create, which is the one that we see on this right-hand side picture. In this diagram, it talks about the structure of the database. So while we were talking about these structures, we are not looking into the data itself, because we simply want to create something that stays there for a long time. If not forever, at least this is something that we don't want to change frequently, because this is the schema design of the database. So once we understand the relational schema diagram, let us move into the next stage, which is looking into the data that can be stored inside of this database. And therefore, assuming we have created the structure based on this relational schema diagram, and then we load the information of the company database into this structure. So what we will see is something like this. You can see that there are like 8 employees inside of the employee table, while they have the DNO, which is the foreign key that referencing the department's primary key, indicating that which departments does each employee works for. Then the department-wise is the same thing. Managers, they do indicating who are the manager using their social security number to reference the employees. And it's the same thing for department locations, projects, including which departments that they are belonging to. Dependents, ESSN is the one that indicating that which employee do they depend on. For the works on, you can see that it has the ESSN number indicating who works on what project, another PNO referencing the primary key of the project, with the attribute indicating how many hours do they have been working on this project. So you can see that this is the data, or what we call the initial status of the data set. In this topic, we want to see what can we do about the data inside of this database. So in this section, we want to concentrate on the database updates and modification of the data. Notice that it is not making changes on the schema, because once we set up the schema, or the schema, a relational schema diagram is set there. We don't want to change the structure, because if we change that, a lot of things inside of this data will have dramatic change as well. So once we look into the data that have been stored over here, we are able to do 3 different operations. They are insert, delete, and modify. So insert indicating I want to insert some new information into the table. When you do that, of course, first of all, you need to tell the DBMS, database management system, that which table you want to insert the information. So saying that you want to insert employee, that means you want to say hire a new employees, that you need to provide their first name, middle name, last name, social security number. Obviously, it's a very important information to be provided because it's the primary key. Birthday, address, gender, salary, supervisor, social security number. This is where our recursive relationship occurs. And remember, when you try to input that information, because it's referencing a social security number, that means the value you put over here has to be existed in the database already. Otherwise, you are referencing someone that's not in the database. That's not going to be valid. Same thing for the department number. In order to talk about which department is that this new employee works for, you need to provide a legit department number. And currently, there are only 3 legit department numbers that you can put over there. So they are all related. On the delete operation means you want to delete an element by giving relation name and key of the tuple. For example, saying that I want to get rid of a project. So same project number 10 is not making any profit. It doesn't make sense to include this project anymore. So what I want to do is that to tell the DBMS, hey, inside of the project, there is one project with P number, the primary key equals to 10. I want to take it off. So ideally, you would be able to simply remove that. However, one problem might occur is that somebody is still working on the project. So you can see that this employee is still working on a project. This employee also working on a project. This employee also works on this project. So there might be some conflicts over there. How do we deal with these conflicts? How do we handle the delete operation is also something we want to look into. Modify. Modify indicating you want to change a value by giving a relation name, key of the target tuple, and the attribute to modify. So saying I want to change someone's salary. What's happening is that I need to tell the DBMS, hey, go into the employee table, look for the person with social security number equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and I want to change as salary to say 1 million. Why not, right? And that is the information you need to provide. So there are several things that might cause a problem, and that's something we want to discuss as well. So let us discuss one thing at a time. So starting from the insert. Insert operation may have the following several things that you need to worry about, including the domain constraint, key constraint, entity integrity, referential integrity. So domain constraint. So saying that you want to insert a new person into the company. While you try to type in, say, their social security number, instead of giving the numbers, the input become characters. That's obviously something not within the domain that we create for the attribute. So that every attribute need to hold some values that's within the domain area. So that's the first thing you need to check for every single one. First name, middle name, last name, social security number, birthday. If they are not giving a date operation, data type, then you are not allowed to insert a value over there. Address, gender, so saying gender has only 2 choices, male or female, and you are inputting something else, then that might conflict with the domain problem. The second one is the key constraint. If the value of the key in the new tuple already exists, then that will cause a big problem. Obviously, if you already have one person, John, with a social security number 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want to insert another person with the same social security number, that will be rejected immediately because you cannot have someone with the same social security number as the primary key. Entity integrity. If the primary key value is null, that's also not allowed. At the same time, if there are some attributes that you indicating it cannot be null, which means that when you put like a star sign on the box, then it cannot be null either. So the null check is also one thing. Finally, referential integrity. If the attribute is a foreign key and you need to reference something that's already there, otherwise it will give you an error message. Just like when you are saying for some new employee who once works for department number 10 and that's not even there, it's obviously going to give you an error message. And therefore, let's take a look at several examples and see how does that work. So saying that if you want to insert a new employee, Cecilia, with first name, middle name, last name, those things are good. However, you see that the null is mapping with the social security number attribute. That obviously is not a good thing. So we will reject the operation because the social security number cannot be null. If we look into the next one, Cecilia as well, now I'm giving that lady a social security number, 999887777. So it will satisfy the not null primary key constraint. However, while we try to look into that, we found there's another person with the same social security number. Obviously, there's something wrong. And therefore, this operation will be rejected as well. So if we looked into the last operation, insert Cecilia with the social security number. Now we have a social security number, and the social security number is a good one. Looking into the birthday, address, gender, salary. Next one, the null value over here is something mapping with supervisor social security number. This is okay. The reason is because inside of the data set, you can see that there's already a person with null value there already. That means this attribute is null allowable. So although it's referencing social security number in as a recursive relationship, null is available, and therefore this null is not the problem for this insert operation. In fact, the problem occurs in here because there is no department number 7, and that's something need to be careful about when you try to do the insert operation. So there are quite a few things, and you need to check one by one and make sure every single operation is valid so that you will be able to insert a new tuple into the database. So this slide gives you the same data that I pulled out over here. So in case you need to look into the information, here is the slides that's available inside of the PowerPoints I provided. So once we looked into the insert operation, we can take a look of the delete operation. Delete operation is actually much easier because there is only one thing that you need to check, which is referential integrity. What I'm trying to say over here is that if I want to delete department number 5, saying research department is not a good department anymore, I want to take it away. However, you need to understand, if you do that, there's actually quite a few tuples that's referencing department number 5 there. That allowing you to delete that just like that, it will cause a lot of problems because all of the tuples already existed will violate the referential integrity. And therefore, we need to make sure that no one is referencing it so that we will be able to delete it. In other words, if you really want to delete research department, you need to assign every single one to a different department first, cancel out all the research department's location, remove all the projects that are belonging to department number 5, and then we would be able to do that. So department number 5 is not existing in any other things, so that you can do the deletion. That is what we call actually the restrict option, and that is the default operation. So if you really want to delete something, you need to make sure nothing is referencing that tuple you want to do the delete. So that is the idea of referential integrity. And that, like I said, is the default operation. Oracle, on the other side, provides you 2 other options. However, you need to understand they are more dangerous. And when you try to create the relationships, these things are there for you to use. But if you don't specify cascade operation or set null operation, restrict is the default operation. So what cascade operation trying to do is that if a record in the parent table is deleted, then the corresponding record in the child table would be automatically deleted. This is like the idea of the employee to the dependent. So if we delete some employees, and since the dependent is a weak entity belonging to the employee, that item will be deleted as well. So you can see that it's a little bit more dangerous. Of course, you can set up everything to the research department using cascade option. And while you try to delete the research department, everything that associated with department research department 5 will be deleted as well. So you need to understand the gravity of this operation. Set null on the other side is a little bit more gentle. So whatever is referencing the item you try to delete, they will let you delete that item. And everything referencing that will have a null value to behold over there. Again, it is okay to do that. However, restrict operation gives you the best as well as the default settings for you to do the delete operation. And therefore, let's take a look of some examples to see when we want to do the delete and under the default setting, which is the restriction, what's going to happen. So if I want to delete the employee tuple with social security number 999887777, so we will look into that. I want to delete Alicia. The immediate problem is that there are actually several informations referencing that person. So you can see the workson has referencing on that one. So for the default setting restrict operation, that operation will be rejected basically. Saying I want to delete another employee with social security number equal to 333445555, that is even worse, because look at the employee table itself. Someone is already referencing that as a supervisor. So of course, this operation will be restricted as well. If we want to delete the works on tuple with the social security number and PNO equals to 10, take a look at this one. This is something I want to mention as well. Saying I want to delete something about this table, works on table. Since this table has a composite primary key, the safest way is provide both primary key here. So you can see this operation saying that ESSN 999AA777. If you only provide that, what's going to happen is that these two tuples will be deleted if you only provide ESSN equals to this social security number over there. And sometimes you don't really mean that, so that if you really want to delete something with composite primary key, it is way much safer to provide both primary keys, so that we will be able to understand this is actually the one that we want to do the deletion. Now, the question is, can we delete that? The answer is yes, we can delete that. Why? Because if we look into the relational schema diagram, you can see the works on over here, there is no arrows pointed at them. So whatever operations that you apply on the deletion for the works on table as well as the dependent table, no checking needed. There's no checking needed. You would basically just delete whatever operation you provided. And that's why if you only provide ESSN equals to 999AA7777, the two tuples in the works on will be deleted. And that's one way, that's how you check for the delete operation. So let me move the data back over here, and let's continue looking to the last operation. The update operation can be tricky. Sometimes it's super easy. Sometimes it's actually even harder than the primary key. So let's take a look what's going to happen on this update operation. So update may violate domain constraint and non-dual constraint on an attribute being modified. So that is the basic thing. If you want to change a tuple into some new data, that new data need to stay inside of the domain, as well as it cannot be null if not null is applied. So that's the basic idea. So the more advanced idea is this. Any of these constraints may also violate it depending on what attribute you want to change. If you want to change a value that is actually a primary key, that's the worst case nightmare, because that is equal to delete the tuple and then insert a new tuple back in. So in other words, if I say I want to modify John's social security number here, saying that that social security number is too common, everybody is using that as an example. Now I want to change my social security number to 0777777777. So what's going to happen is that if I want to do that modification, I'm actually, first of all, I need to delete John Smith. Whoever that's referencing this social security number need to have something to be referenced, right? So this works on is referencing this person right now. By doing that, you are, first of all, you cannot delete John Smith in the first place, and therefore this operation will be denied. So you can see that if you want to change your primary key, it actually requires a lot of operations. So basically, again, you try to delete it and then insert a new tuple with that social security number. If you try to modify a foreign key, saying that, hey, John Smith no longer works for research department, they are promoted, goes into the headquarters. So if you want to change 5 to 1, what's going to do is that you need to make sure you are satisfying the criteria for the foreign key constraint. So the department you try to add must be existed already. If you are trying to updating an ordinary attribute, if it is neither primary key nor foreign key, then domain constraint is the only thing you need to check. And of course, you can easily reference the relational schema diagram to understand that the attribute that you want to change is a primary key or a foreign key. And therefore, these two things need to be worked together. The relational schema diagram as well as the data need to be worked together so that you can be able to determine whether or not these operations are valid. So now let's take a look of some quick examples saying that I want to change an employee tuple with social security number equals to 999887777. So you can see I need to provide the table name, I need to provide the primary key of the tuple that I'm looking at, and then I want to change its salary from 25,000 to 2,800. It's pretty sad. Maybe Alicia has become a part-time position, something like that. But as long as 2,800 is winning the salary domain, then that's a valid operation. Update DNO of employee tuple with 9998777 to 1. So saying that now I want to move her to the headquarters. So I'm changing this from 4 to 1 DNO to 1. Then basically, since department number 1 do exist, we are able to allow that to happen. The next one is again looking to that same person. Instead of department number 1, I want to change her to department number 7. While department 7 is not exist yet, we are not able to do that. Of course, you are able to create a new department over here with department number 7 first. Then you say that, hey, I'm going to assign Alicia to be the manager of that department. Then you can do that. But at this stage, we will need to reject the operation. Finally, update the social security number of employee tuple with this number to this number. So again, this is kind of the operation that I'm changing a primary key. This is obviously easy no over here. So that is the examples about the modification of the data that may occur inside of the database. So finally, I want you guys to do some practice. Make sure you guys understand what I have discussed over here. So suppose that we have each of the following update operations apply on the same table, same relational schema diagram. I want you to tell me that's a valid operation or it's an invalid operation. If it's an invalid operation, you need to give me a reason why it is invalid. And of course, delete operation applies the restrict operation as the default setting. Therefore, I want you guys to take a look of these 3 operations and then submit your answers through the Blackboard to tell me they are valid or invalid operations. The data as well as the relational schema diagram is appended for your convenience, and that would be all for the class today.